Okay, so the recording is on. So hi everyone, I am Anubhav. I am from the electrical department. I'm going to be a sophomore in about a week now, which is kind of scary, to be honest. I've been part of the data-driven astronomy course for the last 2 to 3 months now, and I'm here to sort of talk about my experience, talk about the topics I've covered. I've prepared just a small presentation to sort of put out all the topics. So yeah, just so this is I think week one. So what we did was just basics of Python. We set up Python. We sort of talked about basics Python syntax. Obviously, we covered functions in Python. We talked about multiple packages that might be of use to us. So NumPy, SciPy, Matplotlib, and AstroPy. These four were pretty much the main packages that were covered throughout the course. Quite important packages for other stuff as well, other than maybe SciPy and AstroPy, which was specific to this course. Uh, we sort of our goal throughout this week one was to calculate the mean. So we tried to use Python arrays, basic Python syntax. We were introduced to NumPy arrays because the Python arrays were obviously not particularly uh, quick and memory efficient for large arrays. So we were introduced to NumPy arrays, which were better at that. We sort of had to input data through a CSV file into NumPy arrays. Again, CSV file is quite important for storing data. NumPy array operations, basic NumPy array operations, and then we used NumPy and CSV files to calculate the mean of data sets. So multiple CSV files. Then we were introduced to FITS files, which is something that I found quite fascinating. FITS is basically uh, an image format primarily meant for astro images. So that was quite important in my opinion. We sort of then tried to plot these images using Matplotlib, and then finally we combined it all together so to calculate the mean of a set of fits file using NumPy and fits. Then we sort of talked about if median is better than mean. So again, mean is affected by the outliers, which median is not. So it's better in that aspect. Time and memory I talked about in the previous one. Binaprox algorithm is again another algorithm to calculate the mean, and then we applied this algorithm on fits files. Then we talked about equatorial coordinates, which is again a very theoretical sort of concept. Under that, we talked about right, ascension, and declination. This was primarily meant so that we could just calculate the angular distance, which is basically we just had to write a formula in Python for a basic function using the formulas and all in Python for calculating the angular distance. And then using this angular distance, we sort of cross match between two catalogs. And then we saw two different algorithms for cross matching between these catalogs, which was binary search, which is again a very naive approach of cross matching, and then the second one was KD trees. So KD trees is something that I've never been introduced to before. I found this quite fascinating, and I think this is probably going to come up again in maybe a CS course or something like that. A very interesting concept in my opinion. Databases. This is again the first time I've been introduced to SQL and databases in general. So again, we sort of talked about basic SQL syntax, SQL queries. We sort of talked about different planet statistics, which is basically radius, the sun it is associated to, and all that. And then we talked about multi-planet systems where multiple planets may have the same common star. And then we sort of applied basic SQL queries on these multi-planet systems in order to get specific data. And then but since these tables were not sufficient enough, we sort of tried to create our own databases. We created our own tables, and then we copied the CSV data into those tables, and then we sort of worked with it, which was obviously more efficient. Uh, then finally, in I think week 4, we sort of talked about combining SQL with Python, which I think we did with Psycop G2 module, as far as I remember. So that was something completely new. SQL versus Python, again, a very important topic. Python is basically, the conclusion was that Python is basically good for smaller queries, easier queries, and smaller databases, whereas SQL is meant for more complicated sort of queries and obviously larger databases. So that was week 4. Week 5 was basic decision trees. Decision trees is again something that we have been introduced to, introduced to in CS 101. So again, we applied a regressor using that, and then we talked about its drawbacks, which is overfitting, and that tree depth. Basically, uh, more the depth, we were actually with increase in depth, we were actually losing out on accuracy, which is obviously not ideal. We talked about k-fold cross validation, which is something new. Decision tree classifiers, which classifies into different categories, and then confusion matrices, which is again a very intuitive sort of concept, but I found it to be quite fascinating. Random forest classifiers, again, very important concept. Basically, um apply different decision tree classifiers a bit different, basically parameters for classifying. So we sort of, and then we combined all those decision trees into one single data set. uh, yeah, so this was basically my introduction to sort of machine learning in a way. And yeah, I found it to be quite fascinating. I'll definitely be trying to look more into this machine learning stuff. This is where I think week 5 and 6 started. Basics of digital imaging. Uh, Pixels. We talked about basic pixels, pixel values. What do these pixel values actually represent? We talked about adjustment layers, which is a very important concept for Photoshop and GIMP. We talked about the brightness and contrast adjustment layer for adjusting brightness and contrast, obviously. We talked about non-destructive cropping. Again, cropping is a very important tool. We try to convert colored images into grayscale using black and white adjustment layer. Um, in the lesson two, we talked about histograms. This was probably the most fascinating lessons of all. We talked about bit depth. What does this 8-bit, 16-bit actually represent? We talked about what is the basic difference between these 8-bit and 16-bit images, and can we even sort of see them? Is it even required to go to 16 bits or maybe 32 bits and all that? We saw histograms using the levels adjustment layer, and then we sort of tweak these levels, which is also called histogram stretching, in order to sort of better amplify some features. Like we want to make this space look darker, which is obviously something we expect. And we obviously want to enhance some of the features by increasing the brightness of the, let's say, moon. uh, we talked about what's the effect of changing brightness and contrast. Again, brightness, you increase it, the histogram moves to the right, higher pixel values and all that. uh, the next one was basic image integrity. Is a very theoretical sort of topic. Talked about what image integrity actually means for different people. For journalists, it may be different. For scientists keep like to keep it as raw as possible. They don't like to modify things, and general public doesn't really care too much about these things. They don't really notice these things too much, like corrections and all. So we talked about that we want to do some corrections, but we don't want to go overboard with them. We want to remove some blemishes, but in a limited way. So in order to remove these blemishes, which is basically one of the most common ones, is the black dots on physically present on the camera lens, right? So in order to correct those blemishes, we talked about the pencil tool, the paintbrush tool, again very basic Photoshop and GIMP tools. We talked about the clone stamp tool, which is something I've never heard of before. Healing brush is something I've used quite a bit for colored photos as well, and I think it's an absolutely incredible tool. It's extremely powerful, works very well. Layer blending modes, we sort of talked about. We had to basically assemble image mosaics, manually assemble image mosaics, and in order to do that, we had to sort of overlap two layers. And in order to make those two layers overlap perfectly, we use the difference mode, which is basically subtracts two layers pixel values. So ideally, in order to overlap it perfectly, we want to get zero values, like completely dark. So that is what something we tried to do. We used layer mask, which is sort of to mask out the planet from the dark space uh, behind it, and then we also use the paintbrush tool in order to blend these two layers, blend the seams between the two layers. Yeah. So again, a very important lesson, a very fun lesson to, very hands-on lesson to do. Um, Light levels. We sort of talked about different light levels in space, how these light levels can vary so drastically. We talked about basic definitions of aperture and exposure, something like it's very basic photography sort of stuff. We talked about underexposure, overexposure, again, sort of very basic concepts. Surface reflectance came up in the conversation that usually the moon and the earth look at very similar light levels. But if we see them both in a single image, the moon is a lot darker than this earth. And the reason for that is basically surface reflectance. Moon has a lot less surface reflectance than the earth does. Uh, then we talked about image file formats. Again, this was a very theoretical sort of, but I had a lot of fun because it was sort of mathematical, and we talked about different algorithms used in these compression methods. So basically, we talked about different file formats and how can we reduce the size of our files. So we went through lossless compressions. I don't remember which one of it was it, but I think in general, lossless compressions basically try to find patterns and sort of encode these patterns in for using a shorter representation. So again, you are not losing out on any information, but it still helps in reducing the file size, but not by a large margin though. And then lossy compression methods. These are DCT is basically similar to Fourier transform, where you sort of try and represent your image using multiple cosines of like different amplitudes and frequencies. Again, it quite intuitively it works well with smooth transitions. It does not really work well with images with which have a lot of sharp lines, sharp transitions between them. So that was another algorithm. We talked about downsampling, how we don't always really need that many pixels. Like we could easily downsample a 6000 by 6000 image into let's say 1500 1500, and the size should come down by about a factor of 16. We talked about blurring and then applying lossing operation, another way to sort of reduce the file size drastically. Blurring obviously smoothens out the sharp edges, and then lossing operation works well with without sharp edges. So again, it will help reduce the size even further. Uh, Sizing, I think this was the topics in last 2 weeks. We talked about upsampling and downsampling, both basically resampling and the power of resampling. Like if you sort of want to let's say rotate an image and all that, it's better to sort of upsample it by a factor of let's say 10 and then rotate it and then downsample it back by a factor of 10. That helps in improving the quality rather than just rotating it. We talked about pixel scales and resolving powers, something that something that space cameras usually have to keep in mind. Pixel scales, aspect ratio, very basic photography concept. Different methods of resampling. Basically, when we resample, we have to calculate every single pixel value. So in order to do that, we have different algorithms. So bicubic, bilinear, nearest neighbor, all have different drawbacks. Bicubic, as far as I remember, makes the image quite sharp, which obviously looks bad in a lot of cases if it's overdone. Nearest neighbor it works in a different way. It sort of splits one pixel into let's say four, and then gives all those four pixels the same value as the one before. So those are three different methods. Smart objects is something that I've been introduced to in Illustrator as well, and I've worked with it in basic colored Photoshop images as well. It basically helps while resampling smart objects. You don't really blur the image. You don't really lose it out in quality. So it's obviously quite powerful in that aspect, but obviously it takes a lot more space, and it's obviously you can't really transform it that much. So there's that, and then obviously scale bars. Scale bars are obviously important for sort of visualizing uh, the scale of things, just to keep things in perfect perspective and all that. And I think this was pretty much it. This was all that was covered in sort of the second half of the course. Yeah, I think that's pretty much it. Awesome. So yeah, this was pretty much my opinion on the different topics. I sort of talked about all the topics and how I felt about them. Some of the more fun topics as well. So yeah, that's pretty much it. Awesome. Thanks for watching.